Question 6. This question is about the elements of group 7 of the periodic table and their compounds. Bromine. So Br2 is just two bromine molecules bonded together. Bromine's in group 7, both atoms wanting to gain one electron, so they'll share one electron each in a covalent bond. It'll be molecular, so they'll just be Br2 molecules together, bonded intermolecularly by van der Waals bonds. Strontium chloride SrCl2, so you've got strontium in group 2 and chlorine, two chlorines in group 7. So the strontium will want to lose 2 electrons, each chlorine will want to gain 1 electron, so the strontium will donate electrons to the Cl's. So Sr will become Sr2+, Cl's will become Cl-. There'll be ionic bonding, strong ionic bonding in a lattice in that. And the iodine monochloride, ICl, well, chlorine's slightly more electronegative than iodine. It's smaller and so withdraws electrons towards itself more readily. So that'll have a slight delta minus charge, and the iodine will have a slight delta plus charge. So you'll have polar bonds within the ICl molecules. And so between one ICl molecule and another ICl molecule, the intermolecular bonds will be dipole-dipole attractions. Suggest with reasons the order of the melting points. Well, the one with the highest melting point is going to be strontium chloride SrCl2 because it's ionic in a strong ions held together, strongly attracted in an ionic lattice. Next will be ICl because there's some electronegativity in the Cl, so it's electronegative, so you get polar bonds, delta pluses and delta minuses, delta plus on the I, delta minus on the Cl, and so those polar bonds will create dipole-dipole attractions between the molecules, intermolecular bonds, so it'll have relatively strong intermolecular bonds, whereas Br2 is just molecular, with van der Waals bonds weaker and therefore the lowest boiling point. Write an equation for the reaction of chlorine with cold water. Well, you just got to learn this really. This happens in swimming pools and in drinking water. Chlorine and water forms HCl and something called hypochlorous acid, HClO, which kills bacteria. A disadvantage of treating water in this way. Well, you want to kill bacteria so that when you drink it, it doesn't harm you. But a very small percentage of the water is actually drunk. Quite a lot of it's used for washing clothes, flushing toilets, watering plants, etc. So most of potable water is treated water. Water that's been treated with chlorine is not used for drinking. Bromine reacts with phosphorus to form phosphorus tribromide. Write an equation for this reaction. So we've got Br2 and P4. Phosphorus forms at P4. So don't write just phosphorus on its own. Always put P4. It forms a molecule. It's molecular P4. 4 phosphoruses bond together. So Br2 and P4. It says it makes phosphorus tribromide. So Br3 tribromides, 3 Brs, and therefore P4 you're going to need 4 P Br3s to balance up the 4 Ps, and 12 Brs, you can need 6 Br2s. What's the shape of PBr3? Well, let's have a look. So phosphorus is in group 5 of the periodic table. 3 of the electrons will bond and form 3 bonding pairs, and therefore you've got 2 electrons left over, 1 lone pair. So if it were tetrahedral, if it were 4 bonding pairs, the bond angle would be 109.5. Every time you replace a bonding pair with a lone pair, you reduce the bond angle down by 2.5. So 109.5, take away 2.5, leaves 107. Now you actually don't look at the lone pair of electrons when you're actually discussing the shape. So it's a trigonal pyramid shape with 3 bonding pairs and 1 lone pair. What's the bond angle? Well, it's actually slightly lower than 107.5 because the BRs are slightly larger and therefore trouble to fit close to each other. But if you go with the rule of 109.5 for tetrahedral, and every time there's a lone pair you remove 2.5, so it becomes 107, it fits within the acceptable range. Phosphorus pentabromide in solid state makes PBr4 plus and Br minus ions. Draw the shape of PBr4 plus and suggest its bond angle. Let's have a look then. So phosphorus is in group 5. If it's got 5 electrons in its outer shell, it's plus charge, then it's lost an electron. So instead of 5 in its outer shell, it's now only got 4 in its outer shell. 4 Brs form 4 bonding pairs. These repel equally, and so there's 4 bonding pairs, no lone pairs, into a tetrahedral shape. Remember, if you get more than 3 bonding pairs, then it starts to not be planar anymore and starts to form a 3D shape, with some exceptions like xenon tetrafluoride, etc. But most of the time, after 3 bonding pairs, then it starts to form a a non-planar shape. So we've got bond angle 109.5.